Welcome, students. Let's continue our chapter Matter in Our Surroundings. Today, we are going to discuss about the change of state of matter. We know that matter can exist in three physical states, that's solid state, liquid state, and gaseous state. So, we have water that exists as a solid in the form of ice, liquid in the form of water, and as a gas in the form of steam, in the form of water vapor. Now, water comes out as ice out of freezer of a refrigerator, as water out of a tap, and as steam out of a kettle of boiling water or some vessel of boiling water, right? So we can change the physical state of matter in two ways, either by changing the temperature and or by changing the pressure. So when we say that we can change the state of matter by changing the temperature, we mean that state of matter can be changed by heating or by cooling it. And when we say that we can change the state of matter by changing pressure, then we mean that the state of matter can be changed by increasing the pressure, by compressing it, or by decreasing the pressure on it. Now, this actually the space which is present between the particles, or the force of attraction between the particles, and the amount of movement, kinetic energy of particles can be changed by changing the pressure or by changing the temperature of a substance. So depending on pressure and temperature, the same substance can exist in all the three physical states: solid, liquid, gas. For instance, if we say that under normal pressure, we can see water that exists as a solid in the form of ice at a temperature of 0 degrees Celsius or below that. Then it exists as a liquid in the form of water at room temperature. And as a gas, it exists in the form of steam at a temperature of 100 degrees Celsius or above. So we can conclude that the two factors which decide whether a given substance would be in a solid, liquid, or gaseous state are temperature and pressure. So we will discuss the effect of change of temperature and the effect of change of pressure on the physical state of matter in detail one by one. So let's start with effect of change of temperature. So students, by increasing the temperature, by heating, we can change a solid into liquid state. A liquid can be converted into gaseous state. And when we decrease the temperature or we cool the substance, a gas can be converted into liquid state and a liquid can be converted into solid state. So let's discuss the first conversion of a state of matter, that is solid to liquid change. Let's discuss melting or fusion. So students, see, if we heat ice, it changes to water, right? So is in this case, solid ice changes into liquid water. So a change of state has taken place, right? So the process in which a solid substance changes into a liquid on heating, that is melting or fusion. So when ice changes into water on heating, it's called melting of ice or fusion of ice. So a change of state takes place during the melting, and this melting takes place at a fixed temperature. So the temperature at which a solid substance melts and changes into a liquid at atmospheric pressure, that is called the melting point of the substance. For instance, if we talk about ice melts at a temperature of 0 degrees Celsius and forms liquid water, right? So melting point of ice is 0 degrees Celsius because it starts changing its state at 0 degrees Celsius. So at melting point, ice changes its state from solid to liquid, and different solids have different melting point. If we talk about the melting point of wax, that is 63 degrees Celsius. If we talk about the melting point of iron, that's 1535 degrees Celsius. So the melting point of solid is actually the measure of force of attraction between its particles. See, higher the melting point of a solid substance, then greater will be the force of attraction between its particles. Say, I told you that the melting point of iron is very high. It's 1535 degrees Celsius. Then it's clear that it signifies that the force of attraction between the particles of iron is very strong, right? So when a solid is heated sufficiently, it changes its physical state and becomes a liquid. Now, why this happens? So basically, when a solid substance is heated, heat energy makes its particles vibrate more vigorously. And at the melting point, particles of a solid have sufficient kinetic energy to overcome the strong forces of attraction that's holding them in a fixed position. And when force of attraction is overcome, it breaks and forms small group of particles, and the solid starts melting to form a liquid, right? Now student, here one question arises. Normally, see what happens when we heat a given substance, then its temperature rises, right? But this is not so when a change of state of substance takes place. Because when heat is given to change the physical state of substance from solid to liquid or liquid to gas, there's no rise in temperature of the substance. So basically, we are supplying heat energy, and heat energy has to be supplied to change the state of substance. But the question arises that if we heat energy supplied to the substance, that changes the state of the substance, but it does not raise the temperature, then where does this heat go, right? Then even though we continue to supply heat, then where does this heat energy go if the temperature remains the same, if it does not raise the temperature? So basically, students, the heat energy which has to be supplied to change the state of substance, that is hidden heat. That's called latent heat. Latent means hidden. And it's called latent heat because it becomes hidden in the substance undergoing the change of state. It does not show its presence by raising the temperature. So the latent heat which is given to change the state of substance cannot be detected by thermometer. And see students, every substance has some force of attraction between its particles that holds them together, right? Now if a substance has to change its state, then it is necessary to break the force of attraction between its particles or to weaken the force of attraction between its particles. So the latent heat which we supply is used up in overcoming the forces of attraction between the particles of a substance during the change of state. And this latent heat, it does not increase the kinetic energy of the particles of substance, and since there is no increase in kinetic energy, the temperature does not rise. Okay, and here we are having two types of latent heat. Let's discuss the first one, that is latent heat of fusion. So latent heat of fusion is actually the quantity of heat in joules required to convert 1 kilogram of a solid to liquid at its melting point without any change in temperature. That means we have to supply some quantity of heat by which a solid gets converted into liquid without raising its temperature. That heat which is to be supplied is known as latent heat of fusion, and it has found by experiments that 3.34 into 10 raised to the power 5 joules of heat has to be supplied to change 1 kilogram of ice at the melting point 0 degrees Celsius to water. Okay, so the latent heat of fusion of ice is 3.34 into 10 raised to the power 5 joules per kilogram per kg. So we have seen that when a solid melts on heating, its temperature remains the same. So it does not show any change in its temperature. Why? Because the heat energy which is to be supplied to change its state is used actually in changing the state of solid substance, by overcoming the forces of attraction between its particles. We see, if we take ice and it's a solid substance, see, particles of ice attract one another with strong forces. They are holding the particles closely packed, right? Now, the heat which we supply to ice during melting is all used up to overcome the force of attraction between ice particles so that they become somewhat loose and form liquid water. So, this heat which is supplied does not increase the kinetic energy, and hence there is no rise in temperature during this melting. But yes, when all the ice is melted to form water, further heating increases the kinetic energy of water particles, and due to which then temperature of water starts rising sharply. But when solid is getting converted into liquid, there will be no rise in temperature. Even though you are supplying heat, but that gets utilized in overcoming the forces of attraction, that just changes the state, nothing else. And this is latent heat of fusion. Now, one more thing is here. Tell me, students, ice at 0 degrees Celsius is more effective in cooling a substance than water at 0 degrees Celsius. Definitely, ice at 0 degrees Celsius will be more effective in cooling a substance. Why? Because for melting, each kilogram of ice takes its latent heat from the substance and hence cools the substance more effectively. On the other hand, if we look at water at 0 degrees Celsius, that also takes latent heat from the substance, but that does not take any such latent heat from the substance. Ice takes the latent heat from the substance, so that is why when it takes the latent heat from the substance, heat energy is lost from some substance. That is why it gets cold, right? Gets colder. Okay, that's cool. But water does not. Water 0 degrees Celsius cannot take any such latent heat from the substance. In fact, when we hold a piece of ice in our hand, it feels very cold because when we hold that ice in our hand, it starts melting slowly. And for melting, ice requires some latent heat. Okay, and that ice takes the latent heat from our hand. And when our hand loses heat to ice, we feel it to be cold, right? Okay, so when a solid melts, it absorbs heat to form liquid. Okay, now let's talk about another process that is late that is boiling, or we can say vaporization. Now, the process where a liquid gets converted into gas on heating is known as boiling or vaporization. See, students, water normally exists in the liquid state, right? So, if we go on heating water, it ultimately starts boiling and changes rapidly into a gas called steam, right? So, you can see that liquid water changes into gas. So, this change of state is known as boiling, where a liquid gets converted into gas. And boiling of liquid again takes place at a fixed temperature, and the temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure, that is called the boiling point of the liquid. Say for instance, when water is heated to a temperature of 100 degrees Celsius, it boils to form a gas. So the boiling point of water is 100 degrees Celsius. At boiling point, water changes its state from liquid to gas. Again, different liquids will have different boiling points. Say the boiling point of alcohol is 78 degrees Celsius. So whereas the boiling point of mercury is 357 degrees Celsius. Now again, the boiling point is actually the measure of the force of attraction between its particles. Again, the higher the boiling point of a liquid, greater will be the force of attraction between its particles. So the boiling point of mercury, if I am saying it's 357 degrees Celsius, that tells us that the force of attraction between the particles of mercury is very strong, right? So when a liquid is heated, the heat energy makes its particles move even faster, and at the boiling point the particles have sufficient kinetic energy to overcome the force of attraction that's holding them together and separate into individual particles, and liquid boils to form a gas. So this is the way how liquid gets converted into a gas. Now again, here comes the same thing, that when we supply heat to some substance, it needs to show some change in the temperature, some rise in the temperature. Normally that happens, but here again whenever state change of state of substance takes place, there is no rise in the temperature of the substance. Now here it is latent heat of vaporization. It's actually the quantity of heat in joules required to convert 1 kilogram of liquid at its boiling point to vapor or gas without any change in temperature. And it has been found by experiments that 22.5 into 10 raised to the power 5 joules of heat is required to change 1 kilogram of water at its boiling point at 100 degrees Celsius. And that means the latent heat of vaporization of water is 22.5 into 10 raised to power 5 joules. Now, students, again the same question, that if heat energy is supplied to the boiling liquid and that changes the state of the liquid, then why does this heat energy go if it does not show any rise in temperature? Why the temperature of boiling water does not rise even though heat is being supplied continuously? So basically, again the same thing. If we take water and do the same experiment with water, water is a liquid substance, and particles of water attract one another with certain force, right? So these forces hold the water particles together in liquid state, right? So the heat which we supply to water during boiling is used to overcome the force of attraction. It's used to break the force of attraction between water particles so that they become totally free and start changing into gas. So this latent heat does not increase the kinetic energy, and hence there's no rise in temperature. So basically, heat which is supplied is utilized in changing the state. It does not raise any temperature, it just remains hidden in the substance. So that is why again it's not detected by the thermometer. So when water changes into steam, it absorbs latent heat. Okay, and vice versa is also true. Now tell me, students, whether the burns caused by steam are much more severe or those burns which are caused by boiling water are much more severe. Which burns are more severe? Burns caused by steam or the burns caused by boiling water? Though both of them are at the same temperature of 100 degrees Celsius, steam as well as boiling water. Definitely the burns caused by steam are much more severe. Now why? Again the same reason which we had discussed so far. See, when steam falls on our skin, it condenses to produce water, right? And during the conversion, that means it is condensing to produce water. So during this conversion, it gives out its heat, and it gives out 22.5 into 10 raised power 5 joules per kilogram more heat than boiling water. So steam gives out more heat than boiling water, and when it gives more heat, it can cause more severe burns. So that is why steam is burns caused by steam are more severe. And yeah, steam is better than boiling water for heating purposes because it gives out that much of heat. But yeah, when you need to boil water, when you need to change the state of water to gas, then you have to supply heat. But when vice versa is taking place, when a water is steam is getting converted into water, then it gives out heat, then you don't need to supply heat. Hope it's all clear. Thank you.